Hi everyone, my name is Rishwaar Nair. My registration number is 01DSB23F1048. Today we'll be presenting about application of trigonometry in astronomy. Before that, let me introduce you to my teammates. First of all, there is Mohammad Hidayat bin Mohammad Senin, Hariz Azreen bin Naziruddin, and also Mohammad Hakim Iskandar bin Barudin. Okay, so what is trigonometry? Trigonometry is derived from Greek words tri, which means three, gonon, meaning angles, and metron means measure. Trigonometry is the branch of mathematics that deals with triangle, their sides and angles, the relationship between these, and the associated calculation. It particularly focuses on the trigonometry functions relating to the right-angled triangle. Trigonometry deals with calculating the unknown values of the selected sides of angles. Besides that, the uses of trigonometry are trigonometry and trigonometric functions are widely used in real life for an extensive range of purposes. These uses may include measuring distance and height, locating positions, describing light, sound waves, and analyzing cyclical phenomena. Areas that are able to use trigonometry including architecture, engineering, astronomy, and sports.
Number is 01 DSB 23F1009, and today I'm going to present about right angle triangle. So a right angle triangle is a type of triangle that has one of its angles that are 90 degree and the other two angles sum up to 90 degrees, and the sides that includes the right angle are perpendicular and the base of the triangle. The third side is called the hypotenuse, which is the longest side of all three sides. So the three sides of the right triangle are related to each other. So this relationship is explained by Pythagoras theorem. So these are properties of the right angle triangle. So the length of AC are the hypotenuse, whereas the AB is the opposite, which means it is the opposite with the angles of theta, and the bottom one's line for BC are adjacent. So on the right side is the formula of the sin, cos and theta, and tan of theta. So if you want to get the sin theta, then it is equivalent to opposite over the hypotenuse. Whereas if you want to cos, then cos theta equivalent to adjacent over the hypotenuse. And the lastly is tan theta is equivalent to opposite over the adjacent. So let's talk about the astronomy. So what are the astronomies? So the words of astronomy is derived from the Greek words astro, meaning star, and nomi is derived from the words nomos, which mean law or culture. So it is also known as the law or culture of the stars. And astronomy is a natural science that is study of celestial objects, planets, and star, moon, and nebulas, and galaxy. The physics, chemistry, the mathematics of evolutions of such objects outside the Earth's atmospheres. So let's go to the applications of trigonometry in astronomy.
My name is Mohammad Iskandar bin Barudin. My metric number is 01-B23F1032. Now I want to present about application of trigonometry in astronomy. Since ancient science, trigonometry was used in astronomy. The technique is triangulation is used to measure the distance to nearby stars. In 240 BC, a mathematician named Eratosthenes discovered the radius of the Earth using trigonometry and geometry. In 2001, a group of European astronomers did an experiment that started in 1997 about the distance of Venus from the Sun. Venus was about 105 million kilometers from the Sun. Trigonometry distance to objects within our galaxy is not always a straightforward task. We cannot simply stretch out a measuring tape between two objects and rate of the distance. Instead, a number of techniques have been developed that enables us to measure distance to stars without needing to leave the solar system. One such method is trigonometric parallax, which depends on the apparent motion of nearby stars compared to more distant stars using observation made 6 months apart.
So I'm gonna continue this presentation. My name is Mohammad Hidayat and my metric number is 01TSB23F1030. I'm gonna continue it on example question of trigonometry in astronomy. As you can see on question 1, we need to find the value of x and the theta value is given is equal to 44.3. On the diagram, the x is located between the star and the sun, and the only value are provided is the earth to the sun that is equal to 1 astronomical unit. From the star, the x is on the adjacent side and the earth to the sun are on the opposite side. So we could use the formula of tangent theta is equal to opposite over adjacent. After we determine the formula, we can start to substitute all the values into the formula. We substitute the 1 astronomical unit into the opposite and x into the adjacent. So we get tangent theta is equal to 1 astronomical unit over x. Then tangent theta we need to swap the place with x. As the question provided, theta is equal to 44.3, so it will be x is equal to 1 astronomical unit over tangent 44.3. Using calculator, find the value of 1 astronomical unit divided by tangent 44.3. The answer will be 1.047 astronomical unit. Next, question 2, almost same as question 1. We need to find the value of x and the value of theta is given 44.3. In diagram that are given, x on the opposite side and the only value are provided on the hypotenuse that are 1 astronomical unit. Since we only provided with the opposite and the hypotenuse, the formula that we can use is sin theta is equal to opposite over hypotenuse. After that, we substitute the x into opposite and 1 astronomical unit into hypotenuse. So it will be sin theta is equal to x over 1 astronomical unit. After that, we move the 1 astronomical unit to the other side and it will become times. So now it will be x is equal to sin theta times with 1 astronomical unit. As the question provides, theta is equal to 44.3. So we need to substitute the 44.3 into theta. So now it will be x is equal to sin 44 times 1 astronomical unit. Using calculator, we will get x is equal to 0.6984 astronomical unit. That's all from us. I hope you guys do understand about the application of trigonometry. Bye.